this video will take you through a few examples on how to factorise a quadratic by completing the square. So the first question, x squared plus 10x. So we start off by doing x plus 5 all squared. So whatever that number is, we half it to get that number. And then we square that number in the bracket and we subtract it. And that's completing the square. So if we simplify that, we'll have x plus 5 squared, take away 25. Okay. The same with question 2. Although we're doing x squared, take away 4x this time instead of adding it. So we start off by x minus 2 squared. So again, whatever that number is, we half it and it goes in there. And then we take away that number squared. So our finished answer, we tidy that up for question 2, will be x minus 2 squared, take away 4. Okay. Same if we haven't got a number that's easy to half, we just leave it as a fraction. So in question number 3, we'll have x minus, so 7 divided by 2 is just going to be 7 over 2 squared, take away 7 over 2 squared. And then we simplify that, so we'll have x minus 7 over 2 squared minus, so with the fraction we just do the numerator squared, so it'll be 7 squared is 49 over the denominator squared, which will be 2 squared, which is 4. And we're done. Okay, now question 1, 2 and 3 aren't your normal types of quadratics. Question 4 is the ones you're more familiar with, where you've got 3 terms. So you do exactly the same process. You'll be completing the square on this part of the quadratic here. Okay, so, oh, hang on. That's annoying. So we start off by completing the square on x squared plus 4x. So that'll be x plus 2 squared. So we half the 4. Take away 2 squared. And then don't forget, we've also got this negative 9 on the end. So we simplify all of that. That'll be x plus 2 squared. Take away 4. Take away 9. So that will be x plus 2 squared. Take away 13. Okay, done. Right, so we just have a look at now another 2 harder examples. So you'll see in these 2 questions, there's a coefficient of x squared that's not equal to 1. So in these cases, we can't complete the square straight away. We just have to do something to these expressions. You can only complete the square if the coefficient of x squared is 1. Okay, so in this first one, in question 5, all we're going to do is we'll factorise that first. So we take a 2 outside the bracket, we'll have x squared plus 5 over 2x inside the bracket. Okay, then we can now complete the square of what's inside the bracket. So we'll have 2 brackets. So if I complete the square on this, I'll have x plus, if I half 5 over 2, so that would be 5 over 2 times a half. So that would be 5 over 4. Okay. So inside the bracket, I'll have x plus 5 over 4 squared. Take away 5 over 4 all squared. Okay. Just tidy up inside the bracket first. So I'll have x plus 5 over 4 squared. Take away 5 squared, which is 25, over 4 squared, which is 16. And then if I finish off by multiplying out that bracket, I'll have 2 times x plus 5 over 4 all squared. So that's just going to give me 2 lots of x plus 5 over 4 squared. 2 times 25 over 16. Well, the 2 and the 16 will cancel, leaving me with just 25 over 8. Okay, done. Alright, same when you've got a harder one again with 3 terms in question 6. We can't complete the square straight away because we've got that 3 in front of there. Okay, so we need to get rid of that first. So what we'll do first of all, let's get to that. is I'm just going to factorise just that little bit there. I'm going to leave that one on its own, rather than have to factorise all those terms there. Okay, so on those first two terms, I'm just going to take a 3 outside. That's going to give me x squared minus 5 over 3x inside, and then that one on the outside. Complete the square on the inside. That's going to give me x minus, so 5 over 3 halved. That's going to be 5 over 3 times a half. So that'll be 5 over 6 squared minus 5 squared, which is 25, over 6 squared, which is 36. And then plus that one. So now if I multiply up my squared bracket, I have 3 lots of x minus 5 over 6 squared. Take away, right, 25 over 36 multiplied by the 3, so the 3 and the 36 will cancel, leaving me with 25 over 12. And then don't forget, I've still got that add 1 on that was outside the bracket. So now I'm going to multiply, I'm going to add together negative 25 over 12 plus 1. So I think that's going to be, if I just put that over a common denominator, obviously you can do this bit in your head or on your calculator. Okay, so I'm going to have minus 25, add on 12, so that's going to be minus 13. So I have 3x minus 5 over 6 squared minus 13 over 12, and that's finished. Okay, now we can use completing the square just like with anything else with factorising quadratics. We can also use them to solve equations, which is where, as you remember from last year, that's where the quadratic formula comes from. Okay, so let's do one example where we solve an equation by completing the square. Okay, now remember, when we complete the square, we're going to be doing the process just on that little bit there. Okay, so rather than factorise this and and get rid of that 2 that's just there, what I'm going to start off on this equation is I'm going to take that 7 across to the other side first. Okay, then I'm going to complete the square on 2x squared minus 8x. Now before I do that, I do need to factorise out that 2, because I need a 1 in front of my x squared to be able to complete the square. So if I factorise by 2 first, that'll be 2 brackets x squared minus 4x equals negative 7. If I divide both sides by 2, that's going to give me x squared minus 4x equals minus 7 over 2. Then I'm going to get, if I complete the square on the left hand side, I'll have x minus 2 inside my bracket squared. Take away that 2 squared, so that'll be take away 4, and that's going to be equal to minus 7 over 2. Next thing I want to do now is take that 4 across the other side, and because I don't have my calculator on me, I'm just going to take that 4 across the other side and convert it into a fraction, equivalent fraction with a 2 on the denominator. So that's going to be, instead of add plus 4, plus 8 over 2. Just so I can add those fractions together easily in my head. So that'll give me x minus 2 squared equals minus 7 plus 8. So that's going to give me 1. So that'll be a half. Now if I square root to both sides, I'll get x minus 2 equals plus or minus the square root of a half. And then if I scroll down a little bit so we get a bit more room, take the 2 across the other side, that's going to give me 2 plus or minus the square root of 1 over 2. So that will be, square root of 1 is 1 over root 2. And then if I rationalise the denominator on that third of the 1 over root 2, that's going to give me x is equal to 2 plus or minus, if I rationalise the denominator in this, multiply it by root 2 over root 2, I will get root 2 over 2. my answer. Okay, so completing the square is good for solving equations where it doesn't factorise nice and easily into those two brackets. Okay, and like I said, this is where the quadratic formula comes from. Okay, now if you remember from last year at some point, I asked you to complete the square on the general form of the quadratic equation. So if you'd like to, you can try that again and see if you can come up with the quadratic formula as your answer. Okay. Now there's loads of useful things you can do with completing the square. One of the most useful things you can do is, say if I want to sketch y equals x squared minus x minus 12. I want to know where it crosses the x-axis. I want to know where it crosses the y-axis. And I also want to work out what the minimum point of the graph is. Okay. Now, so we could do this using differentiation, if you think about that. If you pause the video and think about that for a few seconds. Or we could just use completing the square. So if we factorise this really quickly, I'd have y equals, so x minus, right, half of 1 is going to be a half squared. Take away a half squared, so that's going to be 1 squared over 2 squared. And don't forget the 12. Okay. If we tidy that up, that's going to give us x minus a half squared. So that's going to be minus 49 over 4. Okay. Now, your minimum point is going to occur when this expression is at its lowest point it could possibly be. Alright? So we want to think what's the lowest value or the lowest number we could get out of this expression for substituting in different values of x. Okay? And it all revolves around this term here, because it's a square term. And the lowest square number you could get is 0. Okay, if you think about it, you can't square a number and get a negative answer. Okay, at least not yet. So when x minus a half is equal to 0, that would give you your minimum point. So therefore, when x is equal to a half, that would be your minimum point. Okay, now, again, looking at the completed the square form of the quadratic, if that expression inside the orange circle is equal to 0, then the then that would be 0. So this term here would be the number you've got left over with. So if in the orange box is 0, y is going to be equal to negative 49 over 4. Okay, so our y value would be negative 49 over 4. So therefore, using completing the square, our minimum point of that graph would be a half negative 49 over 4. Alright, now if we just use straightforward factorising first, if we look at when y is equal to 0, we'll find out where the graph crosses the x-axis. So we solve x squared minus x minus 12 equals 0. So let's just do that the really quick way, because I can factorise that nice and quickly. That would be x plus 3, x minus 4 equals 0. So I know it's going to cross the x-axis at minus 3 and the x-axis at 4. When x is equal to 0, it'll cross the y-axis. So I'd have 0 squared minus 0 minus 12 is equal to y. So therefore, it crosses the y-axis at minus 12. Okay, we know it's positive x squared. So therefore, we know it's going to be that nice U shape. So if we sketch out axes really quickly, okay, we know it's going to be crossing at minus 3 and 4. Nice U shapes is going to cross here somewhere. It's going to cross here somewhere. and it's going to cross at y equals minus 12, so it's going to cross down there somewhere. Okay, so the minimum point is going to come just after the x-axis. Okay, so that would be at minus 3, that's going to be at 4, that point there would be at 12, and that minimum point down there we know would be a half minus 49 over 4. So there's another use for completing a square. So there's a point to using this. It's actually a lot more useful than doing the old factorising like this one into double brackets. Okay, so you can just get a little bit more out of it. It also allows you to solve any equation as well. Doesn't matter if they don't factorise nicely to two double brackets, you can solve anything. Okay, right, that's it. So watch the video again if you need to, and hopefully that'll help you complete exercise 2 a little easier if you need to. All right, all the best.